So my name is Rick Kunjak. I'm originally from Southern Ontario, from the Niagara region. That's where I grew up. So I'm the first generation son of Croatian immigrants. So both sides of my family are from Croatia. So I grew up in Welland. Welland, Ontario is very much, or was an industrial, sort of very blue-collar town, steel town in Southern Ontario. My grandfather worked for 36 years in the steel plant there. And I grew up next to the Welland Canal, is where my house was. So it's one of how I sort of fell in love with water, fresh water and moving water. From a career perspective, I did my undergrad at the University of Guelph in marine biology. Worked for a while for environmental consulting in the Maritimes, which is when I fell in love with the Maritimes, and then did my master's in Newfoundland at Memorial University, and then back to Waterloo to do my PhD also in fish biology in 1986.
Can you tell us how you got interested in fish biology?
Yeah, that's an easy one because, like I say, I grew up next to the Welland Canal, and my grandfather taught me how to fish before I went to school, but it was all spin fishing that we did. And so because I lived right next to the Welland Canal, I would go down and fish almost every day by myself or with friends. And in fact, my grandfather also built in our backyard, because we had a big backyard with a lot of fruit trees, but he built a small concrete swimming pool for myself and my sister. But I used to use it in the summer for bringing fish home and putting the fish in the swimming pool, and then I would swim with the fish, even at a very young age. So I was always interested in water and interested in fish.
And how they may have changed in the last 20 or 30 years, please.
Right. So when I came to New Brunswick in 1986. And I came as a postdoctoral fellow working with Fisheries and Oceans in Moncton, and started working in the Miramichi. And shortly thereafter started a project called the Catamaran Brook Project, which is a tributary of the Little Southwest Miramichi. And we started working there, and so a lot of that work and the work ever since then has been in fresh water, mostly in rivers. And I was always interested in the whole variety of fishes that were in the river, because my thinking was always that it's an ecosystem and everything is sort of interrelated. And so as much as I was interested in salmon, and much of my mandate as a salmon scientist with DFO was to focus on salmon habitat, I also understood that I need to understand how the other fish is there. So we looked at everything. We looked at the brook trout, we looked at alewives, we looked at slimy sculpin, various species of minnows like black-nosed dace and lake chub. And so we studied all of those different eels, lamprey. We studied all of them in terms of when they moved, how abundant they were relative to salmon. But even in that project, which started in around 89, we continued to electrofish and sample in the rivers in the area within the Miramichi catchment. And salmon were always the most abundant species, unless there was some impassable barrier where they were never able to colonize or to move up above. It was salmon, or else above those barriers, and even in other sections of rivers, it was brook trout. So those were by far, and slimy sculpin, the three most dominant species we sampled, regardless of where we were in the river. And that certainly has changed now. Brook trout aren't nearly as common as they were when I first started doing the work. Salmon are not as abundant as they were. And by contrast, many of the minnow species seem to be more abundant. Even slimy sculpin are not as abundant as they used to be. So these are these tiny little sculpin fishes. And all three of those, the salmon, the trout, and the sculpin, one thing they have in common is they're all cool water fishes. And their numbers have certainly declined as a result of, I think, predominantly because of warming of the rivers. And because, working in the Little Southwest since late 80s, we're now realizing temperatures of over 30 degrees C in the summertime in places. That's far too warm for salmonid fishes and species like slimy sculpin. So they need to find cool places and refuge areas. So yeah, so things have changed. Abundances have changed. And I would, without having the actual data in front of me, I would guess that at least in many of the smaller streams and rivers of the Miramichi, probably biomass. So the total amount of fish, regardless of species, is probably less than it used to be.
Wow. You mentioned the challenge of warmer water. What are some of the other challenges that Atlantic salmon and brook trout are facing these days, please?
In the Miramichi specifically, or?
Yes, yeah, in the Miramichi, please.
So, well, many of us are familiar with the situation with striped bass, and so I think there, because that's a native species, so I mean, it belongs in there. The problem is that the balance is out of whack right now, where there are just too many of these predators in the river to sort of keep a natural or healthy balance there. You know, the Miramichi is an incredibly healthy river still. Doesn't have human-made dams, so it's still a natural flowing river. Yes, it's suffering from climate change, but that's a global issue. And there are still a variety of habitats that can sustain fish, but when things start getting out of balance, in this case something like striped bass, all of a sudden you have too many predators. You know, I remember as an undergrad learning about predator-prey relationships, and these are cyclic over time. You know, it occurs when you'll have too many predators, and sure enough, eventually they'll exhaust their prey resource, and so their numbers will plummet, and then eventually the prey species will increase. And that's certainly happening to some extent in the Miramichi, because remember, salmon are not the primary prey species for striped bass, nor are they the reason we have so many striped bass. Their primary prey species are smelt and alewives, or Gaspereau. And that's what they're depending on. That's what's sustaining them. But striped bass don't care what they eat. Anything that fits in their mouths, they'll eat. And so that's out of balance right now, and that needs to be addressed. And so when you have a low number of fish, in the case where salmon numbers are so low right now for a variety of reasons, the striped bass are certainly a big problem. So back to your initial question, what are the problems? Warming temperatures, or I should say variable climate, because it's not just temperatures, it's also the flashiness of rivers because of the intense rains. Those are affecting our species. Predators like striped bass are certainly affecting it. Invasive species like smallmouth are a concern, not so much in the Miramichi yet, but we certainly know from some recent evidence that those species are starting to spread and could potentially have an impact. So I think those are some of the main problems right now in the Miramichi, because the habitat in general is still remarkably good for salmon habitat in the Miramichi. You look at it, when, you know, regardless of where you are, there is an abundance of spawning habitat. There's an abundance of rearing habitat for juveniles. Because the Miramichi has this moderate gradient, you know, it's one of the few rivers where you can go up any one of the three main branches and access almost the headwaters if you're a migrating salmon. You know, that's incredible when you think about it compared to most river systems. Many scientists who used to work with me over the years from other countries were always remarked at how fortunate we were in the Miramichi to have this incredibly large river system with this very accessible habitat with no human-made dams or other problems, you know, affecting migration patterns. So yes, there are problems, but still a lot of potential for restoration. We used to sample and monitor invertebrate abundance in many of the rivers that we did research in, and the invertebrate abundance is there. So in other words, food for juvenile salmon, trout, sculpin, minnows, great, lots of it, a variety of habitat. Well, yeah, but I mean, even a small stream like Catamaran Brook, so here's this 20-kilometer length of a small stream, like many other tributaries in the Miramichi. And I remember when we started working there, we'd find evidence of these splash dams where they used to hold water back during the forestry activity, and they used to run logs, even down that small stream. Well, you can imagine piling up a bunch of logs in a stream like that, waiting for the spring freshet to come, and then holding back water behind some of these splash dams and releasing these things with all of the logs that would then move down the river, it would have, at a time when all of the eggs were still in the gravel, so not able to move out of the way, and then all of a sudden this jumble of logs that would be disturbing the substrate and the eggs, those would have been a big disturbance for a lot of the salmon.
The
at
striped
time.
bass. What has led to the explosion of that population?
Well, I think it's several things. They're a species that migrates along the whole Atlantic seaboard, so and they like warmer temperatures, so they're moving north because the climate's favorable for them to do so is one of the things. That's why in recent years we're even seeing them in southern Labrador now. That was unheard of before. And then prey. They're following their prey species. So they're following Gaspereau numbers. The problem now is that I always learned a good biologist or a fisheries manager who wants to understand the population he's studying or she's studying wants to know not only what the abundance is of the predator, but what the abundance is of the prey, so that you can understand what's driving these numbers. The problem is now we don't know. We have not estimates on numbers of stripers, but we have, at least I'm unaware of any evidence anymore of the numbers of smelt at Gaspereau, which we used to have at DFO when they used to monitor the commercial fisheries and they'd make estimates. That to me would tell me a lot about what's driving that. But as best I can tell, that's one of the things that these species are doing well because of the favorable climate, allowing them to move north, and favorable numbers of prey species like Gaspereau, at least in the river, because once they move back out to the coastal environment, they're feeding on everything from marine species of fishes to crabs and lobster and everything else.
Could you tell us, Rick, a bit, please, about your understanding of the role of science and research in protecting Atlantic salmon, and who is and who could be conducting this research and scientific study, please?
Sure. Well, I'm a bit biased there because my whole career has been built on doing research, but I'm a believer that it has to go hand in hand, that you need factual information to drive action or management in order to be most effective. So the science working with the managers will help the managers choose the most effective means for realizing their goal or whatever their particular mission is. And the salmon researchers, especially if you're in applied salmon research or applied science, which certainly I was and members of the Canadian Rivers Institute are, is helping in that regard. It's not just, but you need the pure science too. You need the science that's not immediately obvious as to what might be the advantage for management or for some particular activity, but could become fundamental eventually given its findings. So I think you need both, and most of that's driven by academics, but it shouldn't only be. You hear a lot of talk, for instance, and the government science used to be a huge sort of component. I remember when I graduated, both with my master's and my PhD, there were most of us in fisheries science in Canada saw two equally attractive avenues for us to sort of follow up if we were interested in research. Could have gone with the government, or you could go to academia. Both of them were equally interesting. One was a bit more, perhaps more practical, and that is government, because it tended to have a more practical application to assist with management of resources. But they were both very attractive. They both had great opportunities, and they were both regarded highly internationally as two fields to go into to help sort of further your interest in some sort of research. But I think it is fundamental.